Okay, let's see. Okay, start the recording. So, welcome everybody. My name is Walter Cerroni from the University of Bologna in Italy. And I'm going to present, to make introduction, let's say, to this hackathon session during the IETF 108. This hackathon session comes from the activity that myself with Davide Borsatti from the University of Bologna and Molka Garbawi and Barbara Martini from CNIT Italy are carrying on as part of our contribution to the IETF Network Management Research Group. So this is basically part of the work that we've been doing on intent-based networking in the past year, trying to put together actually the common experience that we have also related to some practical demonstration that we made in the past on intent-based networking. In particular, the topic of this session is a multi-level approach to IDN, to intent-based networking. And basically the idea is to try to understand if it makes sense and if it's possible to build an intent-based networking system where you can express intent at different levels, because you may have different needs and also because different stakeholders are involved in the objectives that you want to achieve. So in this sense, having a possibility to define intent interfaces and intent specification at different level could actually improve the flexibility of the whole system. And of course, we need to understand if we have different requirements and different specifications to be performed at different levels. So basically, this presentation will just introduce the main concept that with our colleagues we've been discussing in the past few months about this multi-level approach to IDN. And then we will basically show you how we are trying to implement this idea, in particular in an NFV environment. This is let's say, our playground, although this is not, of course, the only scenario, the only situation that we can apply this concept to. So we're going to present this demonstration, and then, of course, since this is an hackathon session, we would like, of course, to get your feedback, to have any idea, any suggestion on how to improve things, also any critique or any remarks that you may have on what we are doing. And also, there are several points that are still missing in our implementation. So we also discussed this, meaning that there are several components of an intent-based networking system that we still have to develop. And then any experience, an idea, any contribution from people interested in working together would be more than welcome. So, what is an intent-based networking system? Let's just find some common definition and some common ground, because everybody's been talking about intent-based systems in the past few years, and actually we could say that the most common definition is that you with an intent you actually when you apply the intent to the network, in particular the network management, you just want to tell the network what you want to achieve instead of how you want to achieve it. So basically, you are moving from a prescriptive approach, which is typical of traditional network management and configuration system, where you have to follow some kind of recipe to configure and deploy services and, again, configure your network. The idea is to move to something which is more declarative. So basically, you just want to express what is your intent. So what is your intention, what you want to achieve, and what are the outcomes of your request. There has been a lot of discussion, there has been a debate in the past few years about what is an intent-based networking system. And there are also some ideas coming from the industry, of course, something like a piece of networking software that can help to plan, design, and implement or operate the network through some sort of life cycle management software for network infrastructure. And also something that allows you to automate the orchestration, of course, using software platforms, and taking into account, of course, several let's say, systems subsystems that need to monitor, identify, and react in real time what are the network conditions that can be changing, and then in order to also learn. So there is also mention someone mentioning machine learning algorithms, because learning is also an important part of the internet-based networking system, at least as a common understanding. Actually, after all the discussion that has been going on in the past few years, the Network Management Research Group of the IETF is working on this. There are several people involved in this activity, and within the group there are 2 internet drafts that are currently being processed, and so there has been a lot of discussion that brought to these 2 drafts. There's been a lot of movement or a lot of discussion also in the mailing list and in the previous IETF meetings. So something is going on, something is moving towards, let's say, a sort of clear and let's say shared idea of the concepts and the definition. This is especially the first draft, which defines basic ideas on intent-based network. And also there is another draft that is very interesting. Is about intent classification that tries to sort out what actually is an intent and how it can be applied to different stakeholders, different situations, different levels. I'm not going too much into the details, but I invite you to read those drafts if you have not done so yet. I think some of the authors of those drafts are also here, but they are part of the NMRG, so they can definitely talk much better than me about this draft. But I would like to borrow from the draft on concept and definition, because this is what that draft defines as an intent. So a set of operational goals that a network should meet and outcomes that a network is supposed to deliver, defined in a declarative manner without specifying how to achieve or implement them. So this is let's say, the formalization of the common idea of intent that has been around for a while. So we have data abstraction, we have functional abstraction, and the keywords here are basically the desired outcome. If you read through the draft, there is also very interesting discussion about what is an intent compared to policy-based management and service models. And you can see that the idea of this desired outcome is basically the key point here. So again, I invite you to read through these drafts and also participate if you're interested in the next meetings. There will be an NMRG meeting next week during the IETF 108. So I think it's supposed to happen on next Wednesday, if I'm not wrong. So if you're interested, if you want to contribute, there will be a discussion also on these points in the meeting next week. Just to show you something more about this idea of an intent system. This is again taken from the draft, and it shows you the different elements of the life cycle of an intent. Again, there are a lot of concepts here. There are a lot of important aspects that I'm not going through, because it will take a lot of time to discuss this, and they are discussed in the draft. But just to let you know, we basically are working partially on the translation or IBS space that you can see in the center. Actually, we are not exactly doing translation. We are doing more like sort of mapping of an intent expressed as a let's say, the definition of the service that you want to implement, you want to deploy, to be mapped into what we will use as network service descriptions in the NFV environment. So the translation is something different, something more, because it requires some sort of understanding of a high-level common language, which, for instance, is one of the aspects that are still missing in our implementation. And again, this would be one of the interesting points that we welcome contribution for. Also, the part related to learning and planning, this is something that still needs to be developed. Then we, of course, we have all the rightmost part of this figure. We implemented the network operation space when we have the configuration and provisioning of the service, of course, in our infrastructure. Very important is also the bottom part of the life cycle, where you have all the monitoring, observation, validation, and reporting to the user about the intent. This is another point that still requires work, at least in our implementation. And again, any idea, any help, any feedback on a possible contribution, if you are working on this, will be more than welcome. So let's come to this idea of a multi-level intent-based networking system that we are considering. As I said, we are focusing on an NFV scenario where basically the network is deployed as a composition of network function and service components that are running as virtualized objects like virtual machines, containers, and so on, interconnected through virtual links. Although I think the ideas can be extended also to other scenarios. So we consider the case where with this virtualized infrastructure, we can have different partitions, different slices, starting from a common infrastructure, physical infrastructure. So the idea is to consider the approach of the intent-based system applied at different levels. So starting from an infrastructure provider that, of course, knows all the details of the figure infrastructure and whatever is they are running on their infrastructure, they can offer slices as a sort of virtual network infrastructure to what we can call service providers. Service providers can be virtual network operators like satellite operators or mobile virtual network operators, for instance. They can operate their own networks, and this is the first level of intent that they can provide, because they want to obtain some sort of slice of the network infrastructure, and trying to do that in a very high level and with an intent-based approach allows us to define one level for this kind of service request. And then, of course, on top of those slices, we will have customers or vertical services. They want to deploy and running their applications. And this is the second level, the higher level of intent, because this is where the actual service required by a customer is going to be specified in a sort of intent. So basically, the idea is to try to understand how we can apply this idea, this paradigm based on the intent on two different levels that we are representing in this scheme. This is basically an idea that came, as I said, with the collaboration of Barbara Martinez from CNIT. I would like to ask Barbara if she wants to say something more about this, and also the next slide where we actually introduce the ideas of different intents. Barbara, can you open your mic?
Yes, I open my
mic,
and nothing to add to this slide. You gave comprehensive description of the involved stakeholders, and for each of those involved stakeholders, basically we have the different levels of IBM we want to present in the demo. So, if you agree, we can move on to the next slide. So, more precisely, for each stakeholder involved, we have different level of slicing and different scopes where slices are deployed. Different targets. In fact, the infrastructure providers use slices on top of its own infrastructure to deploy their own services, such as mobile networks, in case the infrastructure provider also plays the role of service or content providers. In addition, the infrastructure provider offers slices to service providers as virtual network infrastructures. That's why we have slice here. Can you see my pointer?
Can you see mine?
Okay, so we have a slice component at the level of infrastructure provider and a slice component at the level of a service provider. To highlight that the service providers use slices from the infrastructure provider to deploy customized network services for their customer, such as virtual infrastructures with mobile or satellite capabilities, because typically in our scenario we are considering service provider, we have in mind service providers such as mobile virtual network operators or service providers, service virtual network operators. So basically, service providers might use slices to offer added value services on top of slices for their customer. In general, those high added value services are offered to support and provide higher flexibility and optimization support in the slices, such as SDN capabilities to allow for effective traffic management, for instance, in the satellite virtual networks. I have in mind, for instance, traffic management for interport and over with site diversity in satellite virtual networks. Then service providers offer slices to their customers, typically vertical industry, that use slices to deploy service infrastructure with their application components and service and related service control functions. It is important to highlight that for each slice deployment at any layer, we have a correspondent service chaining settings to regulate traffic among slice service components. So that's why on top of slice we have also service chaining, because typically a slice comes with a service chaining, a set of service chaining that to regulate traffic into the slice among different components. Correspondingly, and here we come to our multi-level intent-based network approach. Correspondingly, we have two different intent concepts, one at the slice concept and the other one to the service chain level. So the slice intent in general express request for a slice and has two levels of components. A set of layer 4, layer 7 virtual functions. We call them top layer virtual functions that include either network.
Oui, on a la caméra. Pour ça, il faudra le mettre sur HAL. Ça te permettra de te citer un peu plus. Toi, c'est parce que si tu fais que sur HAL.
Excuse me, can you close your mic while you're not speaking, please? Okay, Barbara, I think you can resume.
I was saying that we have a set of top layer virtual functions, meaning layer 4, layer 7 virtual function, including either network appliance or vertical application components, strictly layer 7 applications. Then a set of virtual switches and routers, so layer 2, layer 3 virtual network functions, in case in combination with an SDN controller. So these are the main components of what we mean by slice intent. So in general, slice intent should express indications about those components. Then we have the service chain intent that express the request for a service operated on top of the slice through indications about the sequence of the service components running on top of layer 4, layer 7 virtual functions. So indication on how traffic flows should traverse the sequence of service component running into the slice. Where service component strictly mean the layer 4, layer 7 virtual function. So I think we can move to the next slide with more detail. If there are questions, of course, I can take it.
Okay, yes, we can just move to the end of this introduction, then we will ask if there are any questions, and then we move to the demonstration. Now, this idea of different levels for an intent and the different ideas of having a slice intent and a service chain intent, we've been implementing it in some platform to basically towards the NFV scenario. So basically, we use virtual network infrastructure based on mostly on OpenStack. We are also working on the idea of using also Kubernetes. This is still in progress, but we use OpenStack as again the virtualized infrastructure manager to manage the virtual infrastructures. You see that the WIM, the Wide Area Network Infrastructure Manager, is dashed because this is also something that's still missing, that we are still working on this. And on top of that, we need, of course, an orchestrator for this, and we use open source Mano as an NFV enabled orchestrator for doing this. And this is basically those are basically the platform that we are using to run our demo or demonstration. On top of that, we have it's not shown actually here, but we have some customized software layers that are going to expose the intent interface. So basically, we call it intent layer, and where it's basically we send the request formalized. I mean, the intent that expresses the request formalized in a format. It is just a choice to have it formally written in JSON style, but you can actually consider any other kind of formalization for that. And then, of course, there is this intent layer that is going to process this request, and then it's going to fulfill the intent by mapping the request into the proper network service descriptions in the NF3 orchestrator, and then of course apply that request, that descriptors on the infrastructure. Now all the details are going to be shown by David and Molka on their presentation for the demonstration. So this is just to give you an idea of what is the platforms that we are using to prove this approach. Now, basically, what we want to do today in this hackathon session, we want to show you the proof of concept of this multi-level approach to IBN, as I said, in an NFV web framework. So we are going to demonstrate how we set up a slice intent and how we can also set up one or two service chain intents on top of that. And we do that in a very simple scenario where we have a single vim or single point of presence, which of course need to be extended also in other more general scenario, which would involve, for instance, the WIM, the wide area network infrastructure manager, which will involve some sort of interaction with the transport network. Those are still open issues that, again, we would like to have any feedback or any idea or suggestion from anyone who is actually working on that. The idea is also to show you again how we use those platforms, those software platforms, to develop our proof of concept. Because if it's needed, if anyone wants to try their own research or activity based on intent, on the intent approach on our scenario, we can definitely work together and help you configuring and use those platforms if it's needed. And of course, we would like to have feedbacks on possible issues and contributions for further developing this proof of concept. For instance, extended implementation to more complex scenarios. I already say that. Also developing missing components, anything related to the translation from higher level languages, the validation, monitoring and observation, all those aspects that we still have to implement, of course. And as I said, also the interactions with the transport network. So after the demonstration, I hope we will have enough time to have a discussion. And for the sake of a real hackathon event, if possible, try to set up a collaboration either today or maybe in the next few days, or even in the future if it's something that requires more discussion and more interaction in order to try to come up with an improvement of our system. So I think I can stop here. We have before we go to the actual demonstration, I would be happy to answer any questions related to the concept and the idea. Both Barbara and myself are available here. If you have any question or anything to discuss, feel free to open your mic and ask questions.
Hello, this is Ferhat Kendek. I guess you're going to show us how you are expressing the intent,
Yes.
how you are processing them next, right? Yeah.
Yes, exactly.
Okay, that's good. I'm looking forward to that. Yeah.
Okay.
Walter, I have just a clarification. So when you show that there is so when you show that there is like 3 layers, or I mean, I think the second slide, or even here, yeah, here. For example, you said there is like the customer, the service provider, and infrastructure provider, and you talk about multi-level IDN. So in that case, like, does it mean that you, through the IDN layer, let's say, you can interact directly with the service provider or the infrastructure provider, or it's basically the customer requests something through the IBN and it goes down?
It's actually, you have different interactions, because maybe it's better if I show you this. That should be more clear. Basically, if you have a customer that wants to set up a service, you, at least in our idea, what you do is to use what we call the service chain intent. So basically, you have the topmost, the upper layer in your layer, in this layer, the structure, where the customer or the vertical would like to set up a service, and then you have an interaction with the service provider. Now, the service provider, it can be either the same entity as the infrastructure provider, or could be something different. So if the service provider is a virtual network operator, then is the one that is receiving the request, the intent request from the customer. And then the service provider itself that wants to have access to the infrastructure is going to send an intent, a slice intent to the infrastructure provider. So this is how we see the different levels. Of course, yes.
Okay, so but in that case, it will be automatic, I guess. So the user asks for a specific virtual or the specific service, and so the request goes to the service provider, who kind of trigger a new kind of intent specific to this request. But it should be automatic, right? It's not like
it could be. I mean, when we will show the demonstration, we'll have first the service provider asking the slice intent to the infrastructure provider, because he wants to set up a network, a virtual network, and then it's going to offer services to the customer. So you will see that in 2 steps. First, we set up the slice, and then we set up the service on top of that.
All right.
But, I mean, you're right, because at some point maybe you want to use your slice only when needed, or maybe you need to, request more slices because you need to accommodate more services, more traffic. And then in that case, I definitely agree that there should be also the possibility to have an automated setup of the slice intent after you have a new service chain intent that cannot be satisfied with the slices that you already have. So this is definitely something that should be done. Of course, we are not already at that point, but it is something that we can develop further.
I think it will be even clearer with the demo. Thanks.
Yeah. No, thanks for the suggestion. Are there any other questions? If not, actually, I'm not seeing right now the chat or the Slack, so I'm not sure if there are any questions on that. But let me stop sharing. Stop sharing the screen, and then I will pass the presenter role to Davide, who's going to together with Molka to introduce the demonstration. Okay, Davide, you have the presenter role now, so you should be able to share your screen.
Okay. I'll try to. Okay.
It's coming.
Be able to.
Doesn't show up now.
Okay. Let me try again, maybe.
Okay. Now we see the demonstration white
Great.
slide.
Okay. So I think we can start.
Yes.
I think that is done by Mocha. So
Okay, thank you,
let's
Davide.
start the presentation.
You can go to the next slide, please.
Are you
Mocha,
recording?
are
Sorry.
you here?
Yes, the meeting is still being recorded. So
Okay.
Yes, can you hear me?
yes, Murka, we can hear you.
Okay. Thank you, Davide and Walter. You can go to the next
Can
slide.
hear you. Okay.
Okay. So
Do you see my like?
yeah, but you are 3 slides ahead. You have to go.
Yeah, maybe there is some lag with Davide.
Actually, I hear you like very well. So what slide are you seeing right now?
Vim, one back.
Yeah. Okay. Okay.
Okay,
Okay.
thanks.
Okay.
So for this demo, as a reference architecture, we will consider the one defined by HC Energy Group for the management and the orchestration of energy services. So the main building blocks of the architecture are the following. Next slide, please.
Davide, are you still there? Okay. Murka, maybe.
Yeah, maybe it's better that I share and.
Yes. I'm going to give you the.
Yeah, okay.
Okay. You can share now.
Yes. Okay. Are you seeing my screen?
Yes.
Okay. Yes. So we start by the virtualized infrastructure manager. which is responsible for controlling and managing the NFVI resources, such as compute, storage, and networking. Of course, multiple instances of the VM can coexist within the same network to control different distributed resources. The other component is the VNF manager, which is responsible for the lifecycle management of the virtual network function. It mainly handles the creation and the deletion of the VNF and allows for their configuration through specific tools. Mainly the VNF manager modifies the configuration of the VNF and performs the day 1 and day 0 configuration. Finally, the NFV orchestration component is responsible for the orchestrating operations of the network slices under the form of VNF network services. So it also interacts with the VM and the VNF manager and allows for the monitoring of the resources. As previously presented by Walter, in this demo we will consider two different intents, the slice intent and the service chain intent. I will start by the slice intent, which is triggered first, and it's mainly used to express a request for a network SDN-based slice. The slice is mainly composed of two components, a set of applicative virtual functions, which we consider with the following requirements: the type, the geographical location, which is constrained, and the capacity of the virtual machine that will host the VNF. And then the slice contains also a set of virtual switches or virtual routers, which are characterized by their type, their geographical location, and also how these virtual switches are connected among each other. The slice also contains an SDN controller, which is used to manage these virtual switches. So with regard to the HC architecture that I showed before, the slice is deployed within the tenant domain. So you can see here that this is one of the slices that can be deployed using our intent. Once the network service is triggered, the SDN components of the slice are automatically configured and started. So we will have the SDN controller, one or more virtual network functions, and then a set of virtual applications that are automatically attached to the SDN network. Here I show you a template for our slice intent. So the intent is mainly composed of an ID, which is used as a unique string to identify the network slice. Then we have a block which identifies the network functions, which are characterized by their type and location. Currently, we have only one type allowed, which is OVS, which is a virtual switch used to emulate the open flow switches. And then by location, we mean the VM ID on which the VNF will be deployed. If this location is not specified, one random VM among the ones available will be chosen. Then the second block identifies the set of applicative functions that are found within the slice. And these applicative functions are characterized by their type, which up to now we consider firewall, DPI, or load balancer. Then also their location, and then the capacity of the virtual machine that will host these virtual functions. So for the needs of this demo, we have further simplified the intent template, and we kept only three main information, which are the ID, the number of virtual network functions within the slice, and the number of advocative functions. The other parameters that I have showed before are considered as static, and we have set them up within the template. So this is the part that regards to the slice intent. And now I give the floor to Davide to describe the second intent, which is the service chain intent. So Davide, if you hear me, you can.
Okay, so I think we can go on with your screen.
Okay.
For now, and so I'm going to briefly present the service chain intent, which is the intent that the user can use to express a request for a service as a sequence or a chain of service component running on top of like the VNF of that we deployed, for example, during this slice intent that Molka showed you. So in the next slide, we see how it is like composed. So again, is a JSON, which you have the first parameter, which is simply the name of the service. Then you have the slice ID, which identifies on top of which slide this service will be like launched. So on which slide the block are actually or the VF are actually deployed. So, and then we have the list of service blocks, which actually contains the list of these blocks or these function that we need inside our service. And each element of this list is characterized by the name of the VNF that we need and the order. So the order in which to be traversed inside our service path. And finally, a value called symmetric, in which we specify whether the block should be part or not of the reverse path of the chain. And there are also, we thought of adding an additional parameter called service requirement, which is still ongoing. And the idea is to insert there all the parameter related to, for example, the quality of service required or particular network requirement of that particular service. And so this is very briefly was the presentation of our service intent. And this is like the figure showing the testbed that you are using for this demo. The intent layers that you see here refer to an older document of the NMRG group, but we decided to keep it that way because it could be anyway mapped to the life cycle that Walter showed in one of the first slides. And as you can see, right now is just like a simple mapping. So taking the values inside the JSON and trying to map them directly onto the resources available on OSM or on the OpenStack below. As you can see, the slice intent interact only with the NFV Mano, which in this case is made through OSM, which is Etsy's open source solution for realizing the NFV Mano. And while the service intent have to interact also directly with OpenStack, this is like this was needed because OSM does not yet support the possibility of dynamically creating or deleting service chain inside a service. So that's why we had to go directly towards the Vim. And just a couple of words on these two open source projects that we are using. So in next slide, we have a brief presentation of OpenStack, which is, I think that most of you already know what it is, but is just like one of the most famous infrastructure as a service cloud platform, and it's being used in different scenarios from research to commercial. And it provides different types of services such as computing capabilities, virtualized networking, storage, and more. And as you can see from the figure, we are using it as the VM, so the virtualized infrastructure manager for our demo. Then we have OSM, which is, again, as I said, the open source solution, which actually developed, which is compliant, of course, with the SCMano framework. And we are using it for all the function related to the NFV Mano, so the NFVO and the VNFM. Okay, this is very briefly the intent processing flow diagram. On the left, we see the flow diagram for the slice intent, which we have the users that request for a particular slice using the intent. The intent layer will then trigger the correct network service creation on OSM, which again will trigger the deployment of that particular network services on top of the desired VM, or in this case, OpenStack. And then on the right, we have the flow diagram for the service chain intent. It's pretty similar until the SFC creation, because as I said, for the SFC we are talking directly with OpenStack. So you see that the intent layer talks with OSM for the network service creation, that I will explain later on what it will contain. And after the network service deployment on top of OpenStack, the intent layer will talk directly with OpenStack to instantiate the traffic rule for the desired chain. Okay. So this will be the demo workflow. So what are we going to show? So first, using a slice intent, we are going to deploy a slice composed by mainly 3 applicative VNF, for example, a DPI, a firewall, and a load balancer. Then, on top of that slide, we are going to launch 2 different chains. The first one will be the blue one that you are seeing right now, and this will contain all 3 the applicative VNF, and it will be symmetrical, so the same path for the 2 paths, so also for the reverse path, and then the orange one, which will only contain the firewall. Why we decided to do 2 different examples? To show the possibility of creating more slides dynamically on top of the same slice infrastructure launched with the slice intent. And also, the source and destination you're seeing here are actually the 2 virtual functions that we are going to launch also, because we need like a source and a destination for the traffic in order to have a sort of like classifier to decide what is the traffic that will belong to the blue path and what will be the traffic belonging to the orange path. So, okay, if you don't have any other question, I think we can move on with the live demo. So,
stop sharing and I will post you the demo.
Let's see if this time it will work or not.
So I have a question about the intent description.
Okay.
Yeah, if you go back, I mean, you don't have to go back to the template.
For the service chain or for the slice?
I think for both the common hosts for both.
Okay.
It seems to be kind of a low-level intent, like you are specifying basically the blocks, the VNFs that you are putting together, isn't it?
Yeah.
Okay. So you have to specify at that level. Um,
I think this is what Walter presented before, that I think they're missing like
Hello?
this layer on top of it.
I couldn't hear you, the last speaker.
I said I think Walter maybe he will, but he explained, Walter, that I think one of the thing that looking in the hackathon is, yeah, I mean this is the missing part of the translation and like higher level intent.
Okay. This is this part is not there, yeah.
I think what I understand.
Yeah, this is what we have been doing here with Navid, who's attending the meeting. This is this translation part we have been doing for the last 2-3 years actually. So okay, so this is just for clarification for me.
Yeah, and also if I can add something, the idea is to also to, as you should be able to see my screen. So
Yeah, I see. Yeah.
as you can see from like the IBM life cycle, so the intent life cycle, you see that between the recognize / generate intent and the translation / refine block is like almost like a cycle. So it could be like there could be more passage going from the like generation of the intent block to the translation one. And the idea could be that this intent or this form of intent that we are showing could be like the second step. For example, I know that you're working with the high level definition of intents, so almost like natural language. And this could be, for example, mapped inside a JSON structure like ours, for example, as a first step. Then if this is okay for the user, so for the one that generates intent, this could be then moved on with the actually configure and provision phase.
Yes, yeah, exactly. Yeah.
Okay.
Yeah, if I can also add something, that the discussion was definitely on the point. So basically, what we are considering with our JSON-based expression of the intent is that we want to express something like, okay, we know that the slice or the platform in general is providing functions like a firewall, a load balancer, some other components. So basically the intent here that can be definitely seen as a low-level intent is, okay, I want a service that needs to be deployed, including a firewall, a DPI, and then a load balancer in a given order. And maybe we can also decide to say, okay, I want this to be applied only to uplink traffic, but or maybe to both uplink and downlink. So this is basically the meaning of those specifications that we showed. So that's why I was talking at the beginning of a mapping, because basically you know what the system offers you, and then you map your let's say need into how you can compose the service. But this is what is definitely needed, and Mehdi was perfectly right with that, is we need to have a link to someone stating or declaring an intent at a very high level, maybe using some sort of natural language, something like this, and then try to translate it into what we are showing. So if you have any idea or is there any chance we can talk about how to do this, it would be great, definitely.
Yeah, I can send you a link to a paper. We can talk about this, and I can send you a link to a paper. Navid, who's attending the meeting today, has presented this year actually for automating this mapping from a high-level requirement, from a functional, like what are the functions you need, and the quality of services, and the mapping is done with the help of an ontology. So
Great.
I can send you the link to the paper or later.
Yeah.
Yeah.
Great. Thanks a lot.
Okay. Yeah. Thank you.
Okay. If there aren't any more questions, I think we can move on with the demo. I see that Olga raised the hand, so I think you can speak freely.
Can you hear me?
Yeah.
Maybe one of the things here as well would be, but maybe it's for future work to consider, because some of these things may not have to be set per single slice. You may have a kind of network-wide policies that all of the slides that have to go to firewall or something like that, you know. So there is a question if all of these things are the service parts of the service intents, or would they be some kind of network-wide policies as well? So you could maybe look at that approach as well going forward.
Yeah, we're also starting to study the draft related to the different like intent specification classification that we have. So of course, right now what we're showing is limited to a simple, is like limited to the service itself, not to the overall like network wide as you suggested. But of course, it would be interesting in the future to also try to explore different classification of intent, for example, the network wide one that you suggested. Okay. So we can move on, right? Okay.
Yes, I think so.
So we will start with the um, slice intent. So I'm going to show you the status of OSM and of OpenStack right now, which you will see will be empty, and we are going to launch the different things on it. Okay. So here. As you can see right now, we don't have, this is the graphical user interface of OSM. We don't have any network service instantiated, and on our targeted Vim, there is nothing created, just lay managed network, which is statically fixed. So we're going to deploy our first intent. So we're going to deploy the slice, and we made is like a wrapper of the three parameters that Molka described before in the slides, which are the one, let me take the slide back, these three here. So simply by specifying the intent ID or the slice ID at the end, and then the number of network VNF and of applicative VF. So can do it simply. No. Yeah. So this will deploy a slice composed by one network component and three application components. It will take a bit of time, so let's wait. I don't know if meanwhile Molka wants to add something else while we're waiting for the creation of the virtual machines.
Yes, by network components, we mean one open flow switch to which the three applicative virtual functions are directly connected. Within the slice, we have also one SDN controller, which is ONOS, responsible of managing the network components. And for the applicative functions, we have they are only named firewall, DPI, and load balancer, and also they are automatically configured as to their deployment. So once the request is triggered by OSM, you can see that the network service has been deployed, and on OpenStack you can see that we have 4 different virtual machines that are up and running. On top of this, Davide will set up the service chain instance and we then configure the graph.
Yeah, okay. So the machines are up and running, as you can see here, which is like the network topology that OpenStack is showing us. And here on the right, you see the data net of the slides. So the what that we will use to move the traffic between the different VNF, and on the left, the management network that we will just use to access them. As you can see here, we have 3 applicative level function, which are like the firewall, the DPI, and the load balancer, and 1 network component, which is the one called SDN. And as you will see, these names of firewall, DPI, and load balancer are exactly the one that we are using inside the service level intent. You can see here, this is exactly the JSON that we are going to use for launching the first chain that I'm going to remind you will be the blue one. So we will launch a source of destination simply, again, for having like the source of and the destination of the traffic we want to force through this path. And as you can see, it will cross all 3 the applicative VNF. And in fact, if you go back to the intent, you see that there are 3 elements inside this list. The first one is DPI with order 0. Then we have the firewall with order 1. And finally, the load balancer with order 2. So this will be exactly the order on which these function will be traversed. And the slice ID contains the name or the identifier of the slice, which is the one that we can see also here at OSM level, which is the name that we assign to the network services that contains all the different VNF description and network description and so on. So we're going to launch it. And it's simply post towards a post request toward the server that is hosting the intent layer functions. Okay. In a moment, we should see here appearing exactly the network service containing the source of destination of the chain that we are instantiating, and we should see the 2 VM coming up here. One is already, the source is already up. As you can see, the service is has been instantiated, and we have the two endpoint here, so the source and the destination of the traffic. And in order to validate like the chain creation, we can first go and check on the on one of the on OpenStack and see if the chain was actually instantiated or not. Okay, great. So this is the list of service chain currently present inside of OpenStack. We say that we have the one that we just created, so the chain for service A, which is composed of 3 elements here. To exactly prove that these 3 numbers are the related to the 3 applicative function is a bit complicated, so we will just go through. We just like access them through SSH and start traffic, and we will see that the traffic will actually go through the machine that we need. And we'll see that the chain is set as symmetric with true, meaning that it will have the same path for both the forward and reverse path, and is steering traffic based on this classifier that I'm going to print for you. Okay. Just this one, as you can see from the ID here and here. And what it's saying is simply that the traffic that will go through this chain is the one characterized by this parameter. So it will steer all the TCP traffic going from this source to this destination that we can see are exactly the IP addresses on the datanet assigned to the source and destination. As you can see, source as the 10.10.10.187 and 168 for the destination, which are exactly that one that we see here. Okay, so as I said, we can then access them through the management network. So let me take the IP. And I'm accessing also the DPI and the firewall. I will not check also the load balancer simply because it would be a mess with the old terminal screen open, but the expected results are the same also on that machine. So the DPI has address 42. Okay, I entered the machines. You can see here, these are the address that OpenStack showed us on the graphical user interface. And to prove that the chain is actually working, what we're going to do is we are going to capture on the DPI on the firewall on the interface connected to the datanet. Okay. Then we are going to generate traffic between the source and the destination. First, we are going to start with a simple ping. So, and as we saw before, we are steering only TCP traffic, so we are not expecting to see any traffic on the capture on the right side. Let's try it. In fact, as you can see, this type of traffic is different from the what we wanted. So the capture here is empty, while if we do the same thing but with TCP traffic, for example, running a server on port 1234, and on the source side, we're going to connect towards, of course, the IP of the destination and the port that we just opened. And we already saw some traffic, but in order to be clearer, just generate a new package. Okay. So we'll stop the capture. And as you can see, I just typed A and I sent it from the source toward the destination. So as you can see here, has been received. And the capture shows us what? We see a packet coming in inside the DPI and of course going out from the same interface, as you can see from these two MAC addresses. And since the chain is symmetrical, we are expecting also the acknowledge, which is exactly here, which is the acknowledgement of the packet that we see above. And we also see two different ICMP packet redirects, which are simply telling to the source that the packet has been redirected. And the same happens also in on the firewall. We see a packet coming in and going out from the same interface on the first path, and then on the reverse path, the same thing. We see an acknowledgement packet coming in and going out of the same interface, meaning that exactly the packet generating the TCP packets generated from the source are going in the DPI, then the firewall, and again, the load balancer are not showing it just to be more clear with the overall screen, but what is happening is exactly the same. And finally, they are going to destination. And since this chain is symmetrical, also the acknowledgement of all the TCP packets will go through the same path. And again, this was just a demonstration that the chain is actually working. And okay, so the next step would be to go on with the second service, which again is just a way to show you that it's possible to deploy different chain with different characteristics on top of the same slice using, again, the intent. Of course, this time the intent will be a with different. Okay. It will be the intent we're going to use. As you see, we have different name for the service, but we have the same name for the slice ID. So we are going to set up this service on top of the same slice as before. And this time, the service block list is simpler. It's just composed by a single firewall and also with the symmetric flag set to false, meaning that this block will be not part of the reverse path. And the procedure is the same as that one that we saw before. So again, I post request towards the entity in charge of the intent layer, specifying the JSON that I just showed you. And as before, we should see a new service appearing. And we should also see, again, two new endpoints, so another source and another destination for the one called service B. So the source is up. Yeah, and the other one as well. It should be green in a moment. Okay. So the new couple of source and destination have been launched inside of OpenStack, and these are their addresses, and we should see them inside the instantiated chain inside OpenStack as before from the command line. This. So we see that there is a new chain that has been created, the one related to the service B. And since we set the flag of the block of this chain to the symmetric flag to false, also the chain is not symmetric, so it will mean that it will cross this single VNF only once, so only on the first path, not on the reverse path. And we should see also the new flow classifier here, containing the new IP addresses of the source and destination couple, which again are the one here. So this more or less concludes our live demo, and we saw how through these two different intent types it's possible to first deploy a slice, so a set of virtual resources, and how we can set up again with the service intent, we can set up the services, or how we can like chain this applicative function in the way that we want, to serve our particular needs. And also in a dynamic way, so adding new and adding more than one services on top of the same slides, for example. And okay, so we are open to feedback on open issues and even maybe possible contribution. And the first one would be to extend this implementation to a more complex scenario. So in one which we will have more than one VM, because right now we are using just a single OpenStack cluster, as you can see here. So all the requests of the service request and slice request are going towards that single VM. It could be interesting to extend it to cover a multiple VM or multiple point of presence. And also we could be interested to develop or also to gain feedback on missing components, such as the intent translation and refinement, which was the thing that we were talking just before the demo, and also to suggestion for monitoring and observe the status of the services or of the slice. Because as you saw, in order to check if actually the traffic was going through the path that we specified, we have to access all the VMs, start traffic, and capturing on the intermediate VM. It would be, of course, be better if we have like some sort of automated way of knowing that, and also a way to report if this is not working anymore to the user or to the intent layer, depending. And I don't know if Walter wants to add something more after the demo.
Well, not much. I think you showed basically what we intended to prove with this demo. Maybe you can what you could do if there's time to show how the intent were basically translated into the network service descriptions for the open source model, at least related to the let's say the instantiation of the components of the slice and then of the service that were requested by the service chain intent. So anyway, that basically it's all that we wanted to show. Sorry to say that there are still a lot of aspects and a lot of functionalities that are yet to be implemented. So if you have any questions, any idea, any discussion that you want to raise, or anything you want to talk, you want even to present, if you have anything related that could be of interest to this discussion, you're more than welcome to pick up, and we will be happy to have any feedback.
Hi, this is Navid talking. I work under supervision of Dr. Kendick, and I work on in the same topic as it was discussed in the beginning of the meeting. Thank you very much. Very interesting presentation. I have a few questions. First question was, what is the format of NSD that the open manual receives the OSM? I was wondering about that.
Davide, I think you can show us the NSD that were built. Davide? Okay, looks like got disconnected. Sorry about that.
Oh, no worries.
It's coming back.
Yeah, no problem. Uh,
Yeah, sorry, I had some issues with the connection. Sorry.
no problem.
But did you hear the question from?
No, it stopped right when he started. So.
Oh, okay. I'll repeat. No problem.
Thank you.
My first question was I'm wondering about the format of the NSD that the OSM receives.
Okay.
What is the format exactly?
I can show it actually.
Oh, that would be perfect.
To our presenter, yes, you can do it.
Okay. You should be able to see the OSM interface.
Mm-hmm.
And practically, OSM works with the two types of descriptor, which are in form of YAML. And the first one is used to describe the VNF. So this is the VNF descriptor, VNFD, and contains information related to the VNF itself. Meaning, for example, I just opened one of them. Meaning, for example, the image that should be used, what are the interfaces that this machine will have, and also additional configuration in the form of, for example, Cloud Init file. I don't know if you're familiar with that. But basically, in just few words, the VNF descriptor describes the characteristics of the VNF. So how is composed this virtual machine, how many interfaces it has, and how its computing capabilities are. So for example, this is a very small VNF, so just 512 megabyte of RAM, 10 gig of storage, one virtual CPU, and so on. So with this descriptor, we are describing how the VNF is structured. So how the virtual machine basically is structured. Then inside the network service descriptor, we are describing how we want to interconnect the VNF that are part of our service. So this is an example of the network service descriptor. As you can see, we are declaring the VNF descriptor that are part of this network service. So here we are saying we want to create a service with a load balancer, a DPI, and a firewall. And then we are going to specify how we want to connect them. So how is the network, how are the networks between these machines? And we are doing this here, for example. This is the management network, and this is the declaration of the data network. As you see, we are basically saying, okay, we want a network called management, for example, and on that network, we want to connect the firewall through this interface, the DPI through this interface, and so on. This is just very, very briefly how this descriptor works. I don't know if you're interested in something more detailed or more specific.
No, that was good to this point. Thank you.
Okay.
My next question was, so basically you take the intents and you translate them into the NSD, and then into such NSD in YAML file, and you feed the OSM with that, right?
Exactly. Yeah.
Okay. The question was raised in my head was, first, what if, for instance, in the middle of the chain, like it branches out into multiple other branches with the type of intent definition that you have, which just provides the order? Can it be like expressed? Let's say we have a more complex flow with few branches inside.
Yeah.
Or another question would be, what if the VNFs are more complex and they have more interfaces? How do you how your translation detects which interfaces exactly should be connected to should be used for a specific branch of that flow.
That's actually a very good question, and it's something that we also try to answer ourselves. And because this could be also a problem of the underlying infrastructure. So like composing very complex network function with, for example, a simple OpenStack, as in this case, could be complex or maybe even impossible, because we are not sure that the traffic will actually go through a very complex path due to some limitation of the implementation itself.
Right.
And yeah, for example, the branching could be done inside of OpenStack, but if it actually works, so if you actually start generating traffic and you're capturing it, I don't know if it's actually going through that specific path. And yeah, it would be hard to specify that in our intent. But the idea could be, for example, if you take the template or the service chain intent, for example, here in the block name, we use exactly the name of the VNF, but this could be, for example, not the only possibility. So what you are expressing as a service block name could be then decomposed, for example, into a set, for example, of virtual machine connected in a specific way. So if you have, for example, branching, if you want to add branching to this template here, you could, for example, say that that specific block name actually resolves to a specific branch of our chain. So not to a single VNF, but to a complete branch of the chain that we want to set up, for example. This is just like something that I'm thinking of right now, actually. And but yeah,
if I can add something related to this. Actually, we worked on exactly that problem a few years ago. Actually, Davide was not yet working on his PhD at that time. We did try to generalize the idea of expressing a service function chain in a high-level format, specifying the list of VNFs to be crossed, even in case of branching. But that is, I mean, unless you want to go with a graph specification, which complicates, of course, things. If you want to keep it simple, we ended up with something that would actually work, but because at that time we were actually not using OpenStack, we were working low level, working on OpenFlow traffic rules inside virtual switch in order to do that. We managed to do that having, let's say, not a chain after a branch, but only like some sort of terminal network function. For instance, we made the example that at some point you want your traffic to be branched, and one copy of your traffic will go through the rest of the chain, and one copy will reach, for instance, in that case was actually a DPI, but working only as a, you know, as a stub node, with just receiving the traffic, and that's it. So without forwarding further to another chain. So we were able to do that without problems. If you want to branch traffic and then have multiple service components, that becomes a very complicated thing to do with an easy, let's say, an easy way to represent it. You need to use some kind of graph notation in order to do that.
Yeah, that's a complex issue. Thank you so much. Just the final thoughts on the intent. So in this type of representation and the level of details you expect from the intent, if the network and the flow and all those branches get more complex, so you need all those details to be somehow provided in the intent so you can translate it in the NSV. For instance, like if as I raised the question, if the interfaces of VNFs get more and more complex, so in the intent it needs to be specified that which interfaces exactly should be connected and all sort of things. All those details should be provided, right?
Yeah.
Well,
Right
I'm not
now
sure.
is a sort of like I'm hearing some noises. I don't know. Okay. No, right now is sort of can we almost say hard coded, meaning that we know that we want that data traffic is only present on the orange network here. So we actually know what is the type of what are the interfaces connected to that network, and so we know what are basically the port or the interfaces of the machine that will be part of the chain. Of course, if we need a more complex, so with more networks and with machines with that have to pass traffic from one interface to another one, I think there should be more details inside the intent. But I don't know if other has other ideas.
Well, I think that at the intent level, you should not go into the detail considering interfaces, for instance, because that basically bounds your intent to the way that specific connectivity or that connection is being implemented. To my understanding, the intent should be unaware of that.
Yeah, exactly.
The idea here, I'm not sure I already found a solution, of course, but what it should be done here is to try to characterize your service as at a high layer, specifying how your components should interact with each other. And of course, as we said, if at some point you need branches, that makes things very complicated. But I think you should consider, in general, a possible way to represent interactions between components, which is different from, for instance, what you have in the descriptors for the VNFs, where you actually need to mention the interfaces and the network that you want to use to interconnect them. The effort here should be, okay, even if I have a complex VNF, which is made by, I don't know, a number of components with, I don't know, 3 networks and 5 components interacting with each other, I think at the intent level, you should see that as a single entity. And whatever happens inside that VNF, how the traffic is going to be exchanged between the different components on the different networks, it should be some sort of, let's say, high-level characteristics that you want to use. For instance, what we did, because we wanted, for instance, to represent the fact that some traffic flows should cross a given service chain only on the forward path or both on the forward and the reverse path. Because, for instance, if you have, I don't know, a DPI or even better, an intrusion detection system, that network component would like to see the whole traffic going in both directions in order to understand what is going on. So in that case, we came up with this idea to say, okay, we want to realize this service chain, considering that those components, we call them symmetric. Maybe we can find a better way to do that. That means that you have to apply that on both the forward and the reverse path. So, I think this is some sort of high-level expression of what your service should behave, that can be mapped into some low layer configuration. In that case, it has been something related to the service chaining offered by the OpenStack, for instance. So coming back to your question about a complex VNF made by different components, the way those components interact, if it can be abstract and expressed in a high level, for instance, I don't know, I want that component with this option, which means that the traffic is going to do some path, or another option which makes a different path, but expressing it at a high level, especially in terms of what is actually let's use the word, the outcome that we want to achieve. I think that will better fit to the idea of an intent.
Yeah, exactly. Maybe I can just add that in our team we've been working on that aspect actually for the designing of the network services, and using another, like adding another aspect to all these layers, like looking at the functionalities and the dependencies between those functionalities, and we went through that path, and maybe that could be interesting for you as well to look at. And having all those generalizations, we've been I think we've achieved that somehow through having that layer of like abstraction to the level of the functionalities and their dependencies. And we have also proposed an extension to the VNFD to generalize those aspects of the interfaces, that what is their roles and what is their capacities to, not capacity, but what's their, how they, regarding what functionality, in what direction they can send out messages or receive. And I think that could be interesting for you as well.
Yes, definitely. This is definitely something that we should look into.
Okay, thank you so much.
Okay, thank you. I think Mehdi raised his hand. I don't know if Olga, I think she also raised his hand. I don't know who was first.
Yeah, I was wondering about maybe you showed the descriptor. Could you also show the request, instantiation request as well, just to see kind of how the descriptor and the instantiation request are kind of related? And also, I think it would be very useful if you could, in the future, maybe add a diagram that shows kind of input and output artifacts, so that we understand kind of what you are doing, because I think you described the inputs here as different intents and in the demo, and you are showing us what you are generating for the controller. So it would be useful to have maybe a diagram that shows that scope.
Yeah, okay. And
could you,
what
and in terms of the request, service instantiation request, because you showed the NSD, network service descriptor. So I'm just interested to see which information is in the descriptor versus in the service request.
Okay. So regarding the request between like the network service description and its instantiation, there isn't like a single request, but is a series. Basically, OSM decomposes these descriptors. I take this one, which should be simpler, and starts like, okay, I need 2 networks, and starts like posting requests toward the virtual infrastructure manager. So OpenStack in this case, like asking, give me 1 network, give me another one, then give me a VNF like this one and another VNF like this one. So there isn't like a single block request, but it's actually a series of the post requests from OSM to OpenStack. So I can't show you exactly.
Okay, but in regards to the OSM, your communication is sorry, you did show the sequence diagram. We are just sending NSD creation. We are not doing network service instantiation.
Yeah, this is right. Actually, it should be probably corrected in the slide, because we are creating the NSD and we are also triggering its execution. Actually, that is correct.
So okay. So I was just wondering, in terms of properties, what is the part of the descriptor versus what is the part of the instantiation request? So I would assume maybe that you would figure out, I don't know, source destination or something, and send it in the instantiation request, and then descriptors could be reused between multiple source and destinations or something like that. Is that the case?
Yeah, but for the service intent, for example, we are reusing the same VNFD, so VNFD descriptor, and we are using them to compose dynamically a network service, and we are then executing directly or launching the network service on top of the VM. That's like the flow. So yes, this is just this arrow here just show NSD creation, but it's actually NSD creation plus the actually triggering the deployment of the NSD on top of OpenStack.
And you just sorry, another question. Do you create a descriptor per network service instance, or do you have you don't have reuse of network service descriptors between multiple instances?
Right now we are creating different ones, but I think you could also reuse. Yeah.
Okay, that was my comment originally when I was thinking, okay, there are some kind of things that are network-wide policies that could be separate from the intent itself, so that intent itself can become maybe simpler. So in that case, if you maybe decouple intents from those ones which are related to the descriptor versus one which are related to the instances of the service, in that case, you may achieve simplification either of service instances, because then you may not have to have all the imperative information in those.
Yeah, makes sense. Yeah.
Thank you.
Yeah, so my question maybe, or yeah, it's really complete. Olga was asking. Maybe I missed something, but I mean, when you look to your intent, of course, it's a bit, let's say, technical, but it's not that much technical because you're not providing all the technicality of like what is which interface is, and you just like naming the blocks and the interaction between them. So my question is, how do you go from this intent or this template to generating the descriptors like the NSD and the NFD?
Okay, so I think that maybe Molka can start like describing how his slice intent maps towards the network service, and then I can move on with the.
Yeah, actually, we are performing a simple mapping. We are not creating the descriptor from scratch when the intent arrives. So we have already a catalog of descriptors that are already present. And when we receive the intent, mainly, David, if you go to the slice intent template for this demo, we have simply the intent ID, which is specified, of course, for each intent and which should be unique. And then we only specify the number of network functions and applicative functions. So we have only a few examples of descriptors that are already present. So, for example, one network function and two, three, up to 10 applicative virtual functions. So once the intent request arrives, we do a simple mapping, and then we onboard the specific descriptors to OSM model. Of course, this is the first step just to simplify the creation of the network service, and we are planning to make the descriptors more dynamic and to then do somehow first translation test towards more dynamic scenario.
Okay, so you already have some template NSD, NSD.
Yeah, we have a catalog of descriptors to which we associate the intent parameters.
And you map between the request and
the... Yes.
Okay, while ours in this case is simpler because we, in terms of network service, what we do is simply to create a network service composed of these two endpoints here, so the source and destination. And what we are doing is to create again the network service with these two VNF, basically, and we are using the parameter here called slice ID to actually attach our source and couple source and destination to the actual data net of the slice. So they are all pretty similar, the network services here, but what changes is just in case we add like more than one slice. So thanks to the slice ID parameter, we are creating a network service descriptor that connects the our source and destination to the actual data net of that particular slice. So very briefly, this is just what we are doing right now in terms of OSM and network services. And as I said, then we are talking directly with the OpenStack to actually create the element for instantiating a chain inside an OpenStack cluster.
Could I just ask you, could we maybe after, not now, but after the meeting at some point, maybe use our taxonomy as well in the classification draft to position your POC and see if it could be used and if it needs to be extended for usage in your POC. Would that be okay?
Definitely,
Olga. Yeah, same as what you did for the kind of life cycle part.
Yeah, that's definitely what we wanted to do. Actually, I was going through the internet draft that was just promoted or approved a few weeks ago. We just couldn't make it on time for this presentation, but this is exactly what we wanted to do because we wanted to verify all the different taxonomy items and see how can we place actually our idea, our approach to the classification that you prepare. So this is definitely something that we are going to do.
So you can contact myself, Adriana, and we could maybe go through the methodology and see the whole process and see how it can be used in your case, and maybe that could be some joint effort. Thank you.
I would try to, I hope I can be able to present my demo this week. And I think it might be, so I'm using some, some ideas from Alessandro and his team. So I think that might be interesting also to, there is the high level part of the intent where we're using, for example, Google Assistant, talking human beings, so language. So that may be also, can be maybe useful to use it, or some of it, to kind of complete this piece of work, actually.
Sure. Good. Are there any other comment or? It's not. Barbara, I don't know if you want to add anything as a final word.
Just confirm the interest to contribute to the application draft that was already in our plan, and so happy to contribute with taxonomy items.
Thanks.
Then I took notes about all the questions and remarks. So we take them as input, and we sure elaborate them after this demo. Anyway, any proposal on how to add functionalities is more than maybe Walter said.
Yes. Okay. So I think basically we're done. I would like to thank everybody for being here for more than 2 hours actually. But I think it was worth it. It was a very good discussion. Yeah, that was actually the first time we proposed a project for a hackathon, for an IETF hackathon. So maybe it was not exactly, what someone would expect from a hackathon, like with some hands-on work and some contribution. But at least it was a starter, and maybe with the experience and with the further, further collaboration, we can set up something even in that direction in future events like this. But I think it was very good to start this. Of course, if we would have been in a different situation, for instance, in a physical meeting, I think it was supposed to be in Madrid. That would have been different, and also our own work was a little bit slowed down because of the pandemic issue. So we were not able to, at this point, to be as much ready as we wanted to be. So I think we can start from the discussion that we have today, try to improve this system, try to build something together with the other people that were interested in collaborating, and see if we can come up with something more practical, more usable, I would say, the next time. You see the contacts, you know how to reach us. You also have the, if you want, the chance to connect to the Slack workspace that can be used, apart from the hackathon, can be used also as another channel to communicate, to collaborate. And I think we will stay in touch if whoever is interested in going on with this project. And also, if you in your work have any idea and would like to, for instance, use our testbed or try to build a similar testbed like ours for your own testing, for your own development. For instance, if you have any functionality implemented that you wanted to try on an NFV environment, we can help you setting up that. We can help you maybe working on the same environment that we have. So feel free to contact us if you want to, join forces and do something like that. So thank you again. I think we can stop here. I would like to thank Barbara, David, and Molka for helping me with this. Without their contribution, of course, this would not have been possible. And if you have the chance, there will be the meeting next week. I'm not sure if maybe we will present like some sort of a shorter report or short or brief summary of what we did today, and then we will have the chance to talk more on other future meetings of the NMRG. So thanks a lot, and we'll stay in touch and have a nice day.
Bye. Thank you.
Thank you. Bye.
Bye-bye.
Bye. Thank you very much. Bye.
Bye.
Bye.